Hello, in this short lecture I will give you a proof to Pythagorean theorem. Pythagorean theorem relates to a right angle like you see in the picture. The angle between sides B and A is 90 degrees, so it is a right angle, and the Pythagorean theorem claims that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, or the square of the hypotenuse is c squared, and it equals to the sum of a square plus b square. Okay, of c square equals to a square plus b square. In order to prove the theorem, we will make a copy of this triangle. Actually, we will build on side A. We'll build side B like this. This is side B, so B here equals to B here, and then we will raise perpendicular. We will raise a perpendicular to B in size of A. So this will be A, and the angle between A and B is 90 degrees. Here we will do a diagonal line between side A and side B, like this. Actually, we have two diagonals that equals in two sides, because side B in the right diagonal equals to side B, side B in the right diagonal equals to side B in the left diagonal and side A in the right diagonal equals to side A in the left diagonal, and also the angle between side A and side B in the right diagonal is 90 degrees, and so is the angle between side B and side A in the left diagonal. So we have two diagonals that are equal in two sides and also in the angle between those two sides. Therefore, those two diagonals coincide with each other. That is to say, if you have two triangles that equals in two sides and in the angle between those two sides, they are coincide to each other. Therefore, the left diagonal coincides to the right diagonal, the right diagonal coincides to the left diagonal, and therefore this side is also side C, as it is according to the rule of corresponding sides in coincides triangles, because of the fact that those two triangles are coincides to each other. Therefore, this side must be must be side C. Okay, so if we label the angle between side B and side C in the right diagonal as alpha, and the angle between side A and side C in the right diagonal as x, we know that the sum of the angles in every triangle equals to 180 degrees. Therefore, we can say that x plus 90 degrees plus alpha equals to 180 degrees. Okay, x plus 90 degrees. Here is 90 degrees because B is perpendicular to A. That is how we built sides A and B. And plus alpha equals to 180 degrees. We can subtract 90 degrees from both sides of the equation. We will get that x plus alpha equals to 90 degrees, or x equals to 90 degrees minus alpha. So here we have 90 degrees minus alpha. And the angle that in front of A side is alpha. So the angle here must be alpha, according to the rule of corresponding angles in coincides triangles. Okay, the angle in front of A is alpha here, so it must be alpha here, because it is in front of A, of side A. And if we label the angle between side C in the left triangle to the side C in the right triangle as Y, then we also know that the sum of the angles in a straight line is 180 degrees. So we can say that alpha plus y plus x equals to 180 degrees. Yes, alpha plus y plus x equals to 180 degrees. It is correct for every line, every straight line. The sum of the angle on it must be 180 degrees. But we know that x is equals to 90 minus alpha, so we can write that alpha plus y plus 90 minus alpha equals to 180 degrees. Alpha minus alpha equals to 0. And we can subtract alpha minus alpha plus y plus 90 equals 180, y plus 90 equals to 180 degrees, so the angle y equals to 90 degrees. Okay. The angle y equals to 90 degrees. Now we can actually connect to a straight line here between side B and side A. So we have here a trapeze. This is a trapeze, and actually we will calculate the area of the trapeze in two ways, and then we will compare the two expressions. Of course, they are equal to each other. And in this way, we will prove the Pythagoras theorem. So, the first way to calculate the area of the trapeze is actually the area of a trapeze is the sum of the corresponding sides. A is sum of the parallel sides times the height of the trapeze divided by 2. So the parallel sides are A and B. A is parallel to B. So it is A plus B times the height of the trapeze is also A plus B divided by 2. So that is the area of the trapeze, and we can calculate the area of the trapeze in a second way. We can say that the area of the trapeze is equals to the sum of the three triangles that the trapeze contains. So the area of the left triangle plus the area of the middle triangle plus the area of the right triangle equals to the area of the trapeze. So we can say that the area of the trapeze equals to the area of the left triangle. The area of the left triangle equals to its base times its height divided by 2, so it is B times A divided by 2. And plus the area of the middle triangle, that is the base of the triangle times the height divided by 2, so it is C times C divided by 2 plus the area of the right triangle, that is also the base of the triangle times the height divided by 2. So it is A times B divided by 2. So now we will compare the two expressions that we got for the area of the trapeze. We actually will get that the A plus B times A plus B divided by 2 equals to this expression. It is B times A divided by 2 plus C times C divided by 2 plus A times B divided by 2. Here we have A plus B times A plus B. First of all, we will multiply the two sides of the equation by 2. We'll get that A plus B times A plus B equals to a times b plus c squared plus a times b. Then we can open the bracket in the right side of the equation. A times a is equals to a squared plus a times b is ab plus b times a is ba plus b times b is b squared equals to a times b plus a times b is 2ab plus c squared. So here we got a squared plus ab plus ba is 2ab plus b squared equals to 2ab plus c squared. We can deduct 2ab from both sides of this equation. Then we will get that a squared plus b squared equals to c squared. And that is exactly what we needed to prove, that the square of the hypotenuse equals to the sum of the square of the perpendiculars. Okay, a squared plus b squared equals to c squared. Okay, you can see it. Okay. Okay. Thank you very much.